Hi guys, so we're going to do some problems that put area and volume together. So these next 2 days, do 2 phases, we are going to be just taking AP style problems. Most of them will be actually former AP problems, but I don't remember if this one is or not. Maybe it is. Okay, but if it's not an exact AP problem, it's like this type of style. Okay, so I'm going to do here's a review of our area formulas, volume formulas. Take a look at that, okay? And then we're not going to use a calculator for parts A through C, but then there's a part D on the following page, which we will use a calculator for. Okay, so let R be the region in the first quadrant enclosed by the graphs of y equals 2x. All right, so that's the line. And y equals x squared, so that's the parabola. Okay. Part A, find the area of R. So you need to decide if you're going to use top minus bottom, everything in terms of x, right minus left, everything in terms of y. It turns out, guys, you could use either. But since we already have have our equations in terms of x, we might as well just use top minus bottom for x's, but it passes both tests. Okay, so we will just do, okay, so this is part A. All right, guys, this right here should be a very fortunate thing if something like this part A comes up on your test. You know, if you're prepared, this is something you could definitely do. Okay, so we're gonna do the integral, the leftmost x is 0, the rightmost x is 2, and then I'm doing top minus bottom. So the top is 2x, the bottom is x squared. No calculator, so you've got to use the fundamental theorem of calculus. Antiderivative of 2x is x squared. Okay, now I got to plug 2 in, so I'll get 4 minus 8/3 minus, then I got to plug 0 in and I get 0. All right, so that's 12/3 minus 8/3, that is 4/3. Okay, so that is the area of this region. Okay, now I drew the picture over a bunch of times. I do recommend that, guys, like if you're, you know, it makes it a little easier to visualize. Unless you can really visualize it very well, then might be nice to draw it over if you've got to use it more than once. So part B, the region R, same region, is the base of a solid. For this solid, at each x, the cross-section perpendicular to the x-axis has that area. Find the volume of the solid. So guys, we don't know what kind of shapes the cross-sections are, okay? We know that they are being cut perpendicular to the x-axis, so we're going to be using vertical slices, top minus bottom, but we don't know what type of shape this is. I don't know if it's a rectangle, I don't know if it's a triangle, or if it's just some other weird shape. But you know what, just for a nice, easy visual, I'll just do a rectangle, and I'm going to label its area A of x. Okay? So, you know, all of these, and they're jutting up out of the paper and forming this solid, they all have area. Each cross-section has that area. So we got to use a volume formula. That's just where you take the integral of the area function, which they're actually giving us. So top minus bottom, so in terms of x. So the volume is the integral from, in terms of x, so again from 0 to 2, and then the, not top minus bottom, area. So the area goes in. They told, sorry. No, they told us the area, never mind. Okay, so the area, sorry guys, I'm like trying to rush a little. I should relax. Okay, now, guys, it's been a while, but we need to take the antiderivative and we need to use U substitution. This is not just an x. The pi over 2 is inside, is like another function inside of the sine function. So if this were just sine of x, we know its antiderivative is negative cosine. So we could just do that, but the antiderivative of sine of pi over 2x, we don't have a formula for that. So you let u equal pi over 2x. All right, now right now, these are x values. And I want an integral with u values. So for x is 0, you plug that in, you get u is 0. For x is 2, you plug that in here, and you just get pi. Okay, like that. Okay, now, this dx needs to get replaced with a du. So this is where you take what's called the differential. You just go du equals, take the derivative of this, it's just pi over 2, and put a dx at the end. Then you solve for dx. It's 2 over pi du. So where this dx used to be, I'm putting 2 over pi du. And then inside here, this becomes a u. So this is just sine of u. And now everything is in u values. You can pull this 2 over pi. You can pull that out front if you want. Okay, now I'll bring down the 2 over pi. I'm using the fundamental theorem of calculus. The antiderivative of sine is negative cosine. All right, you never plug the u back in because everything is in terms of u now. All right, so this is 2 over pi, negative cosine of pi minus negative cosine of 0. Okay, cosine, there's 0, there's pi. So this is 2 over pi. This is negative 1 for cosine of pi. So that's negative 1 plus cosine of 0 is 1. So we end up getting, this is 2, so we end up getting 4 over pi. Okay, now for C. This one, sometimes they'll say this, guys. Another solid has the same base r. For this solid, the cross sections perpendicular to the y-axis are squares. Write, but do not evaluate an integral expression for the volume of the solid. You just have to set up the formula. You don't have to evaluate it. All right, so if they say write but do not evaluate, pay attention to that because you could spend a lot of time trying to evaluate when you don't have to. All right, so I drew this again. This time, okay. So this time, the cross sections when cut perpendicular to the y-axis are, I forgot what they said, are squares. Okay, nice. All right, so cutting perpendicular to the y-axis, so we've got to use right minus left. And these are squares. Right, left. Now, guys, right minus left in order to get the dimensions. Now, since we're doing horizontal slices, our volume formula is going to be in terms of y, which means, like right now, you know that the line is y equals 2x from the beginning, right? Y equals 2x. But you need to solve for x in order to be able to plug y terms in. So x equals y over 2. So that's the line. All right, and then there's the parabola, which they said is y equals x squared. Okay, but then you take the square root of both sides, so x is plus or minus radical y, but we're in the first quadrant, so it's the plus one. All right, so this line is really x equals y over 2, and then the parabola is x equals radical y, so we're going to be using those. Okay, so Yeah, the area in terms of y, guys, if you want to just find that first, it's just going to be base squared. So it's going to be right minus left squared. The right function in this case is the radical y. The left function is the y over 2. And now you put that into an integral. The bottom y value is 0, the top y value is 4 squared dy. There it is. Okay, so that is the answer. Now, guys, for the last one, all right, we're getting, we're over 2 minutes now. So I just used your judgment. I would keep watching if I were you, but like maybe you already feel super confident with this. But if you don't feel super, super confident, then definitely watch. You could even, if you're bored of watching, try it yourself. But we're going to write an integral to express the volume of the solid generated by revolving this same region as before around the x-axis. Evaluate the integral using Math 9. So guys, if I'm revolving this around the x-axis, I'm going to end up with symmetry, okay? So, I don't know, I'm not great at doing this, but like, so the symmetry will kind of, maybe look like a little bit like that, okay? But remember, it's continuously spinning through the air, and we're revolving around the x-axis. So when I go to do a radius, so this is the center of my rotation. And so I need, I need the radius of it. Okay, this is going to be empty space. And then this is kind of difficult to make look good. But then this part is going to be like what's filled in. We did that way better when I was practicing. But that is a washer. Okay, so we're going to, so that's a washer. Imagine infinitely many of them. Okay, so this is volume, guys. Anytime you have volume, it's going to be the same formula, but just x's or y's. Since the slices are cutting, since the cross sections are cutting vertically, that means in terms of x. So let me just write this down. So a of x dx. So first, let me find the area with respect to x. Guys, for a washer, you need to know the formula of it. So it's pi big radius squared minus little radius squared. So the big radius, all right, so I got to use top minus bottom for both of these. But for the big radius is from the center of the washer all the way out to the end of it. So that's the big radius. So top minus bottom, top is 2x minus the bottom is 0. Okay, then for the small radius, that's the empty space. That goes from the center of the washer out to where like the region begins. That top minus bottom is x squared minus 0. So now, so this is the area of each cross section. Now we just gotta put them inside of an integral. Leftmost x, 0, rightmost 2, pi 2x squared minus x squared squared. Okay, dx. Now they said to use Math 9, so I'm just going to use Math 9. Math 9. Okay, from 0 to 2 pi. Now 2x squared, guys, that's just 4x squared, so I'm just plugging it in like that. Minus, and then x squared squared is just x to the 4th. Okay, but if you're afraid you might make a mistake doing something like that, then just type it in exactly as it is on your paper. 13.404. Okay.